Okay, so in this one here, we're going to take a look at the some of the basic exponent rules. So when we're talking about exponents, we're talking about integer, or powers and things like that. It's important to note just a couple of the piece of terminology. So the number itself, the main number that we're working with, is known as the base. The actual little number that is kind of superscripted at the top there, that is the exponent, and the whole thing is known as a power. So a power is that whole thing. Sometimes we use the word exponent to talk about the whole thing, but technically the exponent means the little number up top there. So this here could be read as 4 to the exponent 3, 4 to the power of 3, or 4 to the third, and then it's usually just we say 4 to the third, but it is 4 to the third power. If we were to factor that out into its component parts, what that means is 4 times 4 times 4. So 4 to the third means multiply 4 by itself 3 times. If the exponents the exponents are only connected to the value that they're touching. So if we take a look at a case of like 3x squared here, the x squared is the only thing that is being affected by the exponent. So the x has the power of 2. It's not the 3. So this is 3 times x. In the next example here, we got negative 4 to the power of 3. Here only the 4 is cubed. So not the negative sign, just the 4. So this is technically a negative 1 to deal with the negative times 4 times 4 times 4. So the 4 is what's being cubed, but not the negative sign. If we want to connect the negative sign, or if we want to connect it with the 3, then we have to put brackets around it. So this whole bracket is 3x, that's all squared. So both the 3 and the x are squared, so it's 3x times 3x, or now we have 3 times 3 and x times x. So only when there's a bracket around the number or the numbers is everything's going to be affected by that exponent. Otherwise, it's just the individual value that the exponent's touching. Now, there are a few exponent rules that we need to be familiar with. We've kind of worked with some of them throughout the course, and that we just haven't explicitly stated them. But if you have exponents bases that are the same and they have an exponent on them, if you multiply exponents with the same base, so both of them here, m and m, then the exponent portion can be added together. So if I have 3 to the power of 4 times 3 to the power of 2, that equals 3 to the power of 4 plus 2, or 3 to the power of 6. And for some people that might seem kind of weird. Why is that? Well, 3 to the power of 4, so I'm going to rewrite it here, and I'll do it in black. 3 to the power of 4 is 3 times 3 times 3 times 3. And then we have 3 to the power of 2 being multiplied, so that's 3 times 3. So there's 3 to the power of 4, there's 3 to the power of 2, so they total up to 3 to the power of 6. And so we just end up adding the exponents. Similarly, when we're dealing with the division of the same base, so we have both the base of m here and we have exponents n and p, we just subtract the exponents. So here I have 3 to the 4 and then over 3 to the 2, so we're dividing. So this works out to 3 to the 4 minus 2, or 3 to the 2. And again, this is 3 times 3 times 3 times 3. There's our 3 to the 4 over 3 times 3. And so what ends up happening is that we can cancel a couple of these 3's, and we're just left with 3 times 3, or 3 squared. Again, that's why that happens. What about if there's a plus or a minus sign between the exponents? Nothing. There is no rule to simplify the exponents if there is a plus or minus sign between each of the powers. So it only works times and divide. If you're multiplying powers of the same base, we add the exponents. If we're dividing powers of the same base, we subtract the exponents. Now, a couple other situations that occur here. If we have a fraction to the power, or to an exponent here, so we have it as a power, then that power just gets distributed amongst the top and bottom numbers. So here we have 3 over 2 to the power of 4. So that's just 3 to the 4 over 2 to the 4. Why, you ask? Again, similar reasoning as before. We have 3 over 2 times 3 over 2 times 3 over 2 times 3 over 2. And when we multiply fractions, it's just the top number. So 3 times 3 times 3 times 3. So that's 3 multiplied by itself 4 times and 2 multiplied by itself 4 times. So that's why it works, but that's all it is it's just spread across both of the terms. And then in the last example here, we have 3 to the power of 4 all to the power of 2. And this, we didn't look at the rule. The rule is if we have power of a power, we multiply those powers. So here it's 3 to the 4 times 2, or 3 to the 8. And again, we can illustrate that. We have 3 to the 4 squared. So that's 3 to the 4 times 3 to the 4. But each of those is 3 times 3 times 3 times 3, and 3 times 3 times 3 times 3. So we have two sets of 3 times 3 times 3 times 3. And there's our 8. So we're multiplying with the same base, we add the exponents. When we're dividing with the same base, we subtract the exponents. Fractions, the exponent gets spread across both terms. And then if we have an exponent on a power, then we just multiply them. Now, little kind of look ahead into some application of this into data management. So those of you looking to take data management next year are going to be looking at some probability. And here's a basic probability concept. So probability is just the number of desired outcomes divided by the number of possible outcomes. If you flip a coin and you want to get heads, what's the chances of getting heads? Well, heads is the desired outcome, so there's one chance of getting heads, and there's two possible outcomes, heads or tails. So flipping a coin, the probability of getting heads is 1 over 2, or 1/2, or 50%. When you divide 1 by 2, you get 0.5, which is, as a decimal, 0.5, but as a percent, 50. So all you're doing is taking the possibilities that you want, divide them by the possibilities that you could get. If there's multiple events and they don't affect each other, like what's the odds of flipping a head 3 times in a row? Then what you do is you just multiply the probabilities. The first probability is 1/2. In your first flip, you can get a head or not get a head, so 50%. And then 50% for the second flip of getting a head, and 50% on the third flip of getting a head. So let's take a look at that concept in terms of a multiple choice test. If you have a 5-question multiple choice test, each question has 4 choices, A, B, C, and D. What's the probability of getting 100% on the test? And I should probably add by guessing. Forgot to add that. So if we're just completely guessing on this test, so we have no clue what the actual answers are, we're just going to randomly pick A, B, C, or D in each of these 5 questions. Well, the first question has 1 correct answer out of 4 possibilities. Question 2 has 1 out of 4 chances of being right. Question 3 has 1 out of 4 chances of being right. Question 4, 1 out of 4 chances, and question 5 has 1 out of 4 chances. So each individual question has a 1 in 4 chance of being right. And some might think, well, hey, then I got a 40 or a 25% chance of being right, a 1 in 4 chance of guessing. However, you'd be wrong because you have to guess each one, and again, the probability is multiplied together. So we actually have 1 to the 4 times 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 1 to the 4, or 1 over 4 to the power of 5. So the probability of, and we'll use G for guessing. That's how we know it. We just usually put probability of whatever we're guessing is 1/4 to the 5. So the probability of guessing and getting 100% is 1 to the 5 over 4 to the 5. Remember, that just spreads between the two. And that would then equal probability of guessing 1, because 1 to the power of 5 is just 1, and 4 to the power of 5 is 1024. So 1 in 1024 is your probability, or as a percentage, 1 divided by 124 or 1024, sorry, is 0.098% approximately. So you have way less than 1% chance of guessing correctly, 100% on a 5-question test, a multiple choice test with 4 choices on each one. So again, what we're doing whenever we have our probability is you just take your probability, and each number of times that you're doing it, that's going to be your exponent. So if we wanted to do the same thing, we'll do a really quick one here. Probability of flipping heads 4 times in a row. So we wanted to do that. Same idea. We have the probability of 4 heads. And what I'm writing in here doesn't matter. That's just keeping me on track, and you'll see that a little more once you get to data management. But that's how we normally, but again, probability of whatever. So the probability of the 4 heads here is going to be, well, 1 head is 1/2 to the power of 4. And so 1/2 to the power of 4, which is equal to 1 to the 4 over 2 to the 4, which is 1 over 16. And so we get 1/16, which as a decimal, or as a percent, sorry, is 6.25%. So that's some application of our exponents when working with some probability situations, and again, something that you'll take a look at next year in some data management.